Okay, let's take a look at the word problems in the section 3.2 notes. So we're told a statistician used data from the U.S. Census to construct this model. S of t equals 21 times natural log of t plus 2, where S of t is the number of cable TV subscribers in millions in year t, where t equals 0 corresponds to the year 1980. We're supposed to use this model to estimate the number of cable TV subscribers in 2015 and the rate of change of the number of subscribers in 2015 to the nearest tenth of a million and interpret the results. Okay, we always start any word problem that involves a function by identifying the input and output. Our input is t, which is a little complicated in this problem. T is representing time in years, but there's a beginning year. T equals 0 is the year 1980. So this data collection started in 1980. So that's our year 0. So for example, if I wanted to do the year 1985, T would be a 5 because that would be 5 years after 1980. If I wanted to do the year 1991, T would be an 11 because that's 11 years after 1980. So we got to do some interpreting with our input. And then what is our output? What is this calculation telling us? Well, it's telling us the number of TV cable subscribers in millions in that year T. Okay, so now that we have the input and output described, we can go ahead and answer the question, and we can come back and use these descriptions as reference to make sure we're getting our interpretation correct. So we're being asked to use this to estimate the number of TV subscribers in 2015. Well, S of t gives us the number of subscribers. So this is just asking us to find S of what? Am I going to plug in the year 2015? No. I'm going to come back and use the idea that 1980 was year 0. So how many years later is the year 2015? What would T be in this case? Well, 2015 is 35 years after 1980. So we're actually going to input T equals 35 into this function, not 2015. And then if I follow the rule, 21 times the natural log of 35 plus 2, that'll calculate the number of TV subscribers in millions, which is what? I got 76.6623. We're being asked to round to the nearest tenth of a million, so I'll round to the nearest tenth there. I'll just round up to 76.7. And again, this is million. This is telling us million cable TV subscribers. Okay. We are also being asked to find the rate of change of the number of subscribers in the year 2015. That means I need to find the derivative of the S function. Well, we can do that. When I look at my original S of t function, the input is being sent to the argument. So we're going to use our log rule to find the derivative of the first term. So let's go ahead and do that. So I wrote out my generic log rule, which I can use here if I recognize that the natural log is really the log log base E of t. Okay, so let's find the derivative using this generic log rule. So my derivative of the first term would be what? Well, the 21 is along for the ride. And then the first part of my rule says to do 1 over the natural log of the base, which is an E. And we know the natural log of E is just 1. That's what makes this the special case. Then we're going to multiply by 1 over the argument. Well, my argument's a plain t, so I'm just going to do 1 over t. And then here comes the chain rule. The chain rule says I have to tack on the derivative of the argument. The input's being sent to the argument, so the chain rule will find the derivative of the argument. But we know the derivative of a plain old variable is just going to be 1. So when I clean all this up, that first term turns out to be 21 times 1 times 1 over t times 1. I don't need those times 1s. And this 21 is technically in a numerator, so I can combine 21 over 1 times 1 over t. I can combine that to just 21 in the numerator and t in the denominator. And don't forget about this other term. We have another term here. We had a plus 2. I need to take the derivative of that, but what is the derivative of a constant? It's just 0. So I don't even need to include that in my final derivative. Adding 0, we don't need to include that. So we have a derivative rule now. So I'm going to plug in the year 2015, which equates to t equals 35. So let's see what we get. 21 over 35. So let me type that in my calculator. I got 0.6. This is the tricky part. We need to interpret this now. How do you interpret a derivative? A derivative is a rate of change. We need to write this over 1 and think about what our change in the outputs is telling us versus the change in the inputs. And that's where that very first step you did way up here is going to help. So change in the outputs. What information was our outputs telling us? The number of cable TV subscribers in millions in year T. So that's what the numerator is telling me. So I really have 0.6 million cable TV subscribers per, the fraction tells me per what? What was the input representing? Time and years. So this is going to be per 1 year. So when I go to write this out in words, this is what it'll look like. Okay, here's my interpretation. In 2015, that was my input for both the original function and the derivative. There were 76.7 million cable TV subscribers. That was the output of my original function. And the units were just number of TV subscribers. And what was happening to that number? The derivative tells me the rate of change. The derivative was positive. So that amount, the number of subscribers, was what? Increasing by 0.6 million subscribers per year. It's important to remember that a derivative is a rate. We're going to see that word per in there. It's comparing outputs to inputs. It's comparing number of subscribers to years. So to get full credit, I need to address what is the input telling me? What are those outputs telling me? Make sure I use correct units, and a derivative is always a rate of change. So you need that word per in there. Now, friendly reminder, on MyMathLab, when you're asked to interpret, you'll select from multiple choice options. Make sure you write a sentence in your own words before you read any of those multiple choice options, because your test will not be multiple choice. And then you say, okay, which one of these multiple choice options best matches what I wrote? And if you're not sure if what you wrote would be acceptable or get you full credit, snap a picture with your phone, email it to me. I can read through it and give you a thumbs up or steer you in the right direction.